Hello, in this video, I'll show you how to add triggers in Firebase Cloud Functions to automatically send notifications to users. There are two ways that you can send notification to an individual or group of users using Firebase Cloud Messaging programmatically. The first method is to allow them to subscribe to a topic and then broadcast the notifications to subscribers of the topic. Another method is to store the registration tokens of each user, and then we can broadcast the notifications using their tokens. Before we begin, be sure to give the video a like, share, and subscribe to support the channel. The first thing we need is to have a Firebase project ready and have it linked with our Android application. Go to console.firebase.google.com. Sign in with your Google account and create a project. Once you have your Firebase project, click on the Android icon in the project overview page. For the package name, use the package name from the main activity file of your application. Then generate a SHA-1 certificate by going back to Android Studio. Click on the Gradle tab on the right, expand the drop-down menu, go to App, Task, Android, and then Signing Report. Copy the SHA-1 certificate in the terminal and paste it inside the text box in Firebase. Click on Register App to continue to the next step. On step 2, download the Google Services.json file and find it. Go to your project on Android Studio and switch to the project view. Place the file inside the app folder. Go to the Firebase console and continue to step 3. Copy the code in the dependencies section and add it to the dependencies section of your project's build Gradle file. Go back to the Firebase console and scroll down until you see the code to add more dependencies. Copy the apply plugin code and add it to the app's build Gradle file in Android Studio. Continue by copying the rest of the dependencies code and add them to the app. Sync the project and wait until the process is finished. In the Firebase console, continue to the next step to complete the process. Once the project is connected with the Android application, we can begin building the service to handle our notifications. Go to the app build Gradle file. In the dependency section, add the Firebase Cloud Messaging dependency and sync the project. Once the process is finished, create a new class called Push Notification Service and have it extend the Firebase Messaging Service class. Override the onMessageReceived method from the Firebase Messaging Service class. The method is called every time it receives a notification from Firebase. We can put our own notification code here to change how the notification will appear. By default, A notification will only appear when the app is closed or in the background. To change this behavior, we must add some code inside this method. The remote message object represents the notification message that was received. We can get the title of the notification by calling getNotification and getTitle. To get the notification text, call getBody. Now let's add the code to display the notification. First, we need to have a notification channel. The purpose of the channel is to establish a link between our app and the Android device. We use this channel to set the behavior of our notifications. It takes 3 parameters. The first parameter is the channel ID. The second parameter is the name of the channel. And the third parameter is the importance level. If we take a look at the Android developer documentation, there are 4 importance levels: high, default, low, and min. With importance high, it will make the notification appear as a pop-up. Go back to Android Studio and use importance high from Notification Manager. Once we have our channel, we need to add the channel to the Android device, call getSystemService, and pass in the Notification Manager class. Then call createNotificationChannel and pass in the channel. Now that the app is linked with the device, we can create the notification object and display it. Use the notification builder to build the notification. Call setContentTitle to set the title. Call setContentText to set the text. Call setSmallIcon to provide a small icon for the notification. And set AutoCancel to true to make the notification go away when we tap on it. The last step we need to do is to send the notification through the channel so it will get displayed. Grab the Notification Manager Compact class. Call the from method, pass in the context, and then call the notify method. It takes 2 parameters. The first parameter is the ID for the notification, and the second is the notification object that we want to send. Now that we have our notification service code set up to handle our incoming notifications, we need to add it inside the manifest file to activate it. This is all we need to start receiving notifications from Firebase. Let's see how we can add triggers in Firebase Cloud Functions to automatically send notifications to users. Make sure you have Node and Firebase tools installed on your computer. Run node-v to get the version of Node you have installed, and Firebase -version for Firebase tools. If you do not have them installed, go to nodejs.org and follow the steps to install Node. For Firebase tools, once you have Node installed, run npm install-g Firebase tools. After you have verified that you have Node and Firebase tools installed, create a folder where it is easy to locate. Open a terminal for that directory and log into Firebase. Afterwards, initialize Firebase Cloud Functions using the Firebase init command. Select the Firebase project you have for the app and continue. Select Yes to install the dependencies. Once Cloud Functions is set, open the project in the code editor. Expand the Functions folder and go to the index.js file. To define a function for Cloud Functions, grab the exports object and use the dot operator to add a name for the function. Take the functions object and get the Firestore module. To check if a document is added to a collection, call document, then on create. Inside the parentheses of document, pass in the location of where you want to detect. For example, if we have a collection called notifications, the path we will use will be notifications to represent the collection, and the document ID to represent the document. Instead of using a static value to represent a single document, wrap the document ID with the curly brackets to represent any document. The onCreate function represents the action we want to detect. Whenever a document is created on this path, we'll run this block of code. This will be our trigger to send notifications to users. To send a notification to users who subscribe to a topic, import Firebase admin and initialize the app. Inside the trigger function, grab the admin object, get the messaging module, and call the send to topic function. It takes two parameters. The first is the topic we want to broadcast, and the second is the object that contains the notification information. The next thing we need to do is to deploy this function to Cloud Functions to activate the trigger. Save the project and run the deploy command in the terminal. Make sure your Firebase project is upgraded to the Blaze plan before executing the command. Once the deployment is completed, go to the Firebase console. In the Functions tab, you should see the function in the system. Now that we have our trigger set up, we need to let the user subscribe to the topic we're broadcasting to. Go to the main activity of your Android application. Import Firebase messaging and create an instance. To subscribe to a topic, take the Firebase messaging object. Call the subscribe to topic method and pass in the topic you want to subscribe to. Since we're broadcasting to the new user forum topic, we'll put new user forums. If we run the application and add a document to the notifications collection, a notification will appear. To reiterate what is happening in the background, when we launch our Android application, the user will subscribe to the new user forum topic. Then whenever a document is added to the notifications collection, Cloud Functions will automatically fire off the trigger function and run the code to broadcast the message. When the message is sent in our notification service, it will create a notification and display it on the device. Now instead of receiving the same notification information every time we add a new document, we can customize the notification by using the data from the document. Go back to Cloud Functions. The snapshot object represents the document that was added to the collection. We can access the data from the document by taking the snapshot object and calling the data function. Then we can use the dot operator to get the value of the property. The same can be done with body. Save the project and deploy the function again to update in Firebase. Now when we add a new document with a title and body, it will use those values in the notification. Now let's see how we can send notifications to users using registration tokens. When you implement the Firebase Cloud Messaging SDK to your app, it will automatically generate a unique token for the device when the app is launched for the first time. The idea is to store the tokens in an online storage such as Firestore and retrieve them in Cloud Functions. To begin, go to the app build Gradle file and implement the Firestore module. Sync the project and wait for the process to finish. Once the process is completed, go to the push notification service class and override the onNewToken method from the Firebase messaging service class. The onNewToken method is called every time it receives a registration token from the Firebase Cloud Messaging SDK. This is where you want to put the code to upload a token to an online storage. Generally, it will not give you a new token unless the app was reinstalled or if the user clears the app data from the settings. The string parameter returned represents the token value. Create a map to store the token so we can upload it to Firestore. Then create an instance of Firestore and use the collection, document, and set methods to upload the token. Indicate the collection that you want to add the document to by providing the name of the collection in the collection method. Now that we have a way to obtain and upload the token information, we need to make sure that we can upload data to Firestore. Go to the Firebase console. Click on the Firestore database tab. In the Rules tab, change false to true so we can read and write data. Then publish it so changes will be saved. In Android Studio, stop the app. In the emulator, uninstall it and relaunch the app in Android Studio. This way, we'll get a new token. When the app is up and running, you should see a collection called device tokens in the Firestore database. And inside the collection is a document with the token information. Go to the index.js file of the Cloud Functions project. Delete the code in the trigger function. To get the tokens in the device tokens collection, grab the admin object. Get the Firestore module, call the collection function, and pass in the name of the collection you want to access. Lastly, call get, and then to retrieve the data. The result object returned represents a snapshot of the documents currently in the collection. Create an array called registration tokens. Then loop through all the documents and add each token into the array. Once we have the tokens, grab the admin object, get the messaging module, and call the send multicast function to send a notification to the owners of the tokens. Pass in the JSON object and set the tokens property with the registration tokens. Then set the notifications property and pass in the title and body. Save the project and deploy the function again to update it. If we add the document to the notifications collection, the function will trigger and it will send a notification to our device. That's all for this video. If you find this video helpful, please give it a like, share, and subscribe to support the channel. See you in the next video.